Hi Gabby, here's how you do it. It's really quite simple when you get the hang of it. There's truck B, there's truck A. So we'll call that force 1 and we'll call that force 2. So then on the next page it asks you to draw a diagram. For starters, your diagram is 90 degrees the wrong way. So what we'll do is we'll start again. So it says use a scale of 1 centimetre equals 500 newtons. So it's important to write 1 centimetre equals, right, my pen's packed in, there's a flying start in it, equals 500 newtons. So force 1 is going to be vehicle A is 4,000 and vehicle B is 2. So that arrow straight down is vehicle B. So that's going to be obviously 4 centimetres long. So it's important when you're doing this to start off with a little dot. And what you're supposed to do is go down 4 centimetres. Like that. Because it's a force, you should always put an arrow at the end and label it. So we'll call that F1. We'll just put 2,000 there so we know, yeah? And now we need the other angle 45 degrees different. So if we put that there, starting from force 1, we can go, I don't know which way to show you this actually. I'll show you the way you're supposed to do it and then I'll show you a little cheat you can do. So even though that's the origin, what we do here is we start there and we go 45 degrees. So where are the degrees on? I need my reading glasses, sorry. So we've got 10, 90, 10, 20, 30, 40, 5. So that's 45 degrees. So then if we draw another line from here at 8 centimetres, crossing over that line that we did, you've then got this. So you draw your force 2 after the end of your force 1, using that as a reference. So that is F2, and that is 4,000. Now, here's your answer. If we get this, and we draw a line from there to the end, yeah, then that is exactly 11 centimetres. So that should actually be, just so you can see, that should actually be a different colour, just so, because teachers love this kind of thing. So that is 11 centimetres, and we'll call that is called the resulting vector, I believe, or something like that. So we'll just call that V for vector. The angle, so it's 11 centimetres, and its angle is, hang on, let's put that right there. It's just a cheap protractor, this. So, so the angle is 24 degrees. 24 degrees. So the scale that you said was 500 newtons per centimetre. So it was 11 centimetres. So half 11, what do you get? And the angle is 24 degrees. Let me show you another way of doing it, because that's drawing from there. You can end up drawing a parallelogram if you prefer this method. So again, 4 centimetres down. So there's the start. Go there. Go 4 centimetres there. Draw an arrow. And then, if you prefer this angle, let's do 45 degrees again. So we'll put that there. 40 5. There's that. So then this line needs to be 8 centimetres long. So this gets you the same answer as the other one, hopefully. So there. So that's F1 and that's F2. So now, how do you work out the angle? You turn each of these into a parallelogram. So we've got to draw another 45-degree angle from here. Starting there, 45. And this just needs to be 8 centimetres long, and hopefully that's the only thing we need to measure. So because this is just a guide, we just can do this quite faint. So these, and then we can just draw that, link that to there. So you're basically turning, you start off into a parallelogram, and then what you do is you draw a vector that connects opposite corners. This is your resulting vector, yeah? So hopefully, it is a cheap protractor, bear in mind, hopefully the answer will be the same as the first one. So, yep, we've got a line 11 centimetres long, which is just like before, and the angle of this is the angle is 40. And, oh, sorry, I was measuring that, saying 45. I was thinking something's weird then. So again, it looks like it is 28 degrees this time. I can't recall what my answer was on the first page, but 24 degrees. But that's because I've got a cheap protractor. So that's how you do vector equations. So the proper way to do it, draw your second vector from there. But if you prefer to do the origin, then you just make an imaginary parallelogram. Link the two up, measure that, and that's your answer.